Okay, so we are doing 8.7. As you notice, 8.6 we are now skipping, and I'll talk about what 8.6 is about. Okay. So 8.7, the name of this title is Growth and Decay. So we'll look at a couple of problems which have growth and decay. So basically this is the formula that we are looking at, but I want to tell you an easy way to, you won't be given this formula, we are supposed to know this formula. We are supposed to know this formula. Anytime you have a situation where they tell you that the data is growing exponentially, you say exponentially, or data is growing continuously. What are the other words when we come across that? But these are the two words that come to my mind. If they ever say the population of so and so place is growing exponentially, or the population of so and so place is growing continuously, if you see words like these, you have to use the exponential growth formula, exponential growth or decay formula. How do you remember this formula? Okay, so this formula actually, if we had done 8.6, we would have seen a particular formula called the PERT formula. The PERT formula is, okay, I'm going to go ahead and write this down, what the PERT formula is and how it's related. It's exactly the same thing. The PERT formula is basically, like I said, it came from a financial situation, financial institutions, where if you say that the money is growing continuously or the money is growing exponentially, the formula that was used is, this is the final amount. The final amount is principal amount multiplied by E, because remember that whole E came from calculating compound interest, 1 plus 1 over n, to the power of R and T. So that's why this is called PERT. I'm sorry, here we go. APERT. So that's why the formula of any data that is growing exponentially is called as the PERT formula. It's a very common thing. Oh, it's the PERT formula because it's growing exponentially. This is exactly the same as this, except written differently. How is this? This is the final amount. AT is also the final amount. You can write either this way or this way. AT is the final amount after time t. After this time t, the amount reaches. Instead of the principal amount, we call it A0. When the time is 0, you start with the initial amount. So initial amount, instead of calling it P, we call it A0. E stays the same. R can stay the same. You can either call it R. A lot of times for some reason, they replace R with K. K, R, all of them are basically rate of growth. And because it's a constant, they use the alphabet K. And then T is for time. So they are exactly the same formula, except just some of the alphabets are replaced. So, but this is an easy one to remember because it specifically says PERT. And in the PERT formula, the equivalent of that in a non-financial situation is A0ERT, but it's the same thing. Right? Everybody clear about what I just said? So that, like I said, this formula is not given to you. You have to know the PERT formula. Okay, let's go ahead and write down what are the different things in the PERT formulas. And the PERT formula is AT is the size of the population at any time t. So after time t, what is the population? And then A0 is the population, the original, when you're just starting off, what is the original population is 0. K or R, whatever you may call it. For now I'm writing K, but it can also be replaced as an R, is the rate of growth. That's why R, it's the rate of growth. And what's missing is T. I don't know why they forgotten the T. T is the time. It is taken to grow from, it says here time, yeah, T, but T is basically time. Time is taken to grow from A0 to AT. Okay, here, if the K, I just want you to write this down, and I'm not sure how much we'll use it, but if K is greater than 0, the rate of growth is greater than 0, the population grows or increases. This is the, forgetting the words, give me 1 second. Okay, law or okay, I'm just going to write one. Okay, let me write both just in case. The law of uninhibited growth. Sometimes don't see that of uninhibited growth. See, uninhibited growth is the same as exponential growth or exponential growth. Exponential growth is what I see and what I remember personally, but I think sometimes they use an uninhibited growth also. And if k is less than 0, the population decreases or decays. Instead of growth, it's decay. That's all. That's all. So 1 is growth, k is greater than 0, it's a growth, and it's less than 0, it's decay. Okay. There are better problems in the back section, so I'm going to go there, but I'll just wait for people to finish writing. Let's go to the next page. So we look at problem 4 and 5. Let's start with 4. Alright, so this one says a culture of bacteria obeys the law of uninhibited growth. So they do use that. So the minute you see this, the fact that the data is growing uninhibited or exponentially, you want to write the formula down. The formula is final amount equals initial amount multiply. So basically PERT. So P, instead of P you write A0, E R T. The formula, you want to write down the formula because you're going to use that formula. And let's see in this formula, what are they given us, what are they asking us. If 300 bacteria are present initially, so 300 is what, guys? 300 bacteria is present initially. A0, that's the initial amount. Everybody good? There are 500 bacteria after 1 hour. My final amount is 500 when the time is 1 hour. When the time is 1 hour. This is the information they're giving us. How many will be present in the same culture after 4 hours? For me to calculate how much will 300 grow to in 4 hours, what is the one thing that's missing? How I will not be able to find out without what? I need to calculate the 80. So for me to here, so this is what I'm trying to solve. How many will be present after 4 hours? So I know my T will change to 4. I have my initial amount to be 300. My new amount is what I'm trying to calculate. But what do I need? K, perfect. So R is unknown. R is unknown. Without R, I will not, without the rate of growth, I don't know how much 300 will grow to in 4 hours. Right? So, but they have given me enough, that's why they're giving me the first statement. If 300 bacteria are present and there are 500 after 1 hour, that will allow me to calculate the rate of growth. So step 1 is always calculate K or R or whatever you may call it. I've said R here, so yeah, K or R, whichever. Okay, so can we all write down our formula and fill everything in except R? Because I know 80, I know A0, E is E is a constant, remember, R is the unknown, T is 1. So let's all write. So before we answer the question, let's all go ahead and solve for K or R. AT is 500, A0 is 300, E to the power of R times 1 is just R. This 1, so I don't need to worry about it, right? So I don't need to write it also. Okay, so now everybody okay with the statement? So now my question to you is, what kind of an equation are we trying to solve here? Someone said exponential. Perfect. This is an exponential because what are we trying to solve here? It's the same as x. So this statement this one is nothing but 500 equals 300 e to the power of x, where we're trying to solve for x, right? Does this make sense? Your goal is to solve for this x. Can we all solve? We all learned just now. We all did a review of how to solve an exponential equation, where the base cannot be the same. So can we all solve for this x and tell me what you get? So R is your variable that you're trying to solve. R is the variable that you're trying to solve. Very good. Divide by 300 on both sides because you want to isolate the term that contains x or R. So e to the power of R equals, oh, my R is really bad. Okay, e to the power of R equals 5 over 3. Now how do you get R by itself? It's an exponential equation. How do you solve an exponential equation? Rewrite it as log. So let's go ahead and rewrite it as a log with a base e. Is everybody clear? First step, and you'll see that in the next problem, you'll see on both the problems on the review packet, the first step will always be to solve for K. First step will always be to solve for K. Now we'll answer this question. There are two questions they're asking us. One is, I'm going to call one of them A. How many will be present in the same culture after 4 hours? And then question number 2, how long is it until it reaches 10,000 bacteria? We'll get to this in a minute, but let's go ahead and solve the first one. How many will be present in the same culture after 4 hours? So what are they asking us to find? Right? They want us to know how much bacteria after 4 hours. So final amount. Initial amount stays the same, but you're still starting with the same situation. Everybody okay? E KT or RT, so to the power of ln of 5 over 3 multiplied by 4 because it is after 4 hours. Does this make sense? Should you be putting ln of 5 over 3? Okay, we should talk about this. Should we be putting ln of 5 over 3 in your calculator and finding the value? Because this is a constant. The answer is no, because what will happen is you're going to get an approximate value. So you will be raising e to an approximate value. In exponential equations, calculations, even a small difference in any of your calculations, the exponent brings a big change because exponential data grows very quickly. So you want to keep the value exact. You approximate only as a final step. Okay, so how do I find this 80 now? What do I need to do? I need to manipulate anything here? Is there anything on the left hand side that needs to that is unknown? Is there anything here? I want all of you to look at this. Is there anything here that I need to find? Is there a variable there? No, nothing. Perfect. Good answer. So I can just put this whole thing in my calculator to solve for 80. So let's go ahead and do that. If you don't have a calculator, please come and get one. You should practice with the calculator.
Do we have a calculator in class?
Yes, there'll be one calculator section. Yeah. Just put your name back. Yeah. So I've written 300, but I realized that we have never really seen E on the calculator. E, like I've been saying, it's a constant like pi, so it's actually very close to the pi. Do you guys see the clear button? Below clear button is a caret, below that is E. So, or it's just the second of the division symbol, just about division symbol you'll see E. Can everybody locate it? So you'll do second and division symbol and you should get E. Everybody okay? Everybody got E? Okay? To the power is your caret symbol. And then please open parentheses because there are two elements in the exponent, so you want to put them together in a parentheses. So open parentheses and then ln of 5 divided by 3 close parentheses multiplied by 4 and close the entire parentheses, and you can get out of the exponent. This is what you should see. Can everybody see? 300 multiplied by E to the power of 4 times ln of 5 by 3. Did I say negative? What did I do? I made a mistake. Everybody okay? Did we all get this? Okay, I'm going to go ahead and write down the answer so you can see it more clearly. I think the calculator is not clear. So it's 2314.8 number of bacteria. Final amount, sorry, I should say 4. Final amount after 4 hours is this much. And if you didn't get it, please let me know. I can come over to help you. If you're not sure about how to use a calculator or it's not working for you, let me know so I can show you. And then I would like all of you to read the second part. I'm just going to highlight the second part. It's also underlined. But can we all read the second part? How long? Here they're asking us to find the time. They're giving you the final amount. The final amount is 10,000. So AT is 10,000 and they are telling us to solve for T. So if you can all just think about how to solve for T, everything else is there. You have R, you have AT, you have A0, only the T is missing. So go ahead and write the equation, see if you can figure out. I will come and help you, but I will need you to start figuring out.
Two elements in the adapter. So yeah, that's okay. So go ahead and open parentheses and then we ln of 5 over 3 and close parentheses and then multiply by 4 and close parentheses and there you go. Okay, so what will be checking about it? Then you put exponent, just make sure you put everything in parentheses. So they put two elements, ln of 5 over 3 multiply by 4. Yeah, is that good?
Yeah. Anybody else not sure about the calculator? Oh, right here. Right here. Yeah. 5 over 3 divided by 3. Close and then close parentheses multiplied by 4 and then close parentheses. And yeah, there you go. Yeah, good.
Thank you.
All right, I hope we sort of started it and kind of got the hang of it, because as always it's good to do stuff by yourself. So let's look at B. After how long will it reach 10,000? So 10,000 is my AT. A0 is still 300, hasn't changed. Everybody okay so far? E is e to the power of ln of phi by 3 multiplied by t. This is how your statement is going to look like. This is how your statement is going to look like. Again, what's your goal here? To get the t, correct? T is your x. T is your x. And what do you notice? T is in your exponent. T is in the exponent. That means you're solving an exponential equation. The minute the x is in the exponent, you're solving an exponential equation. You're solving an exponential equation where you can't equate the basis. That strategy is gone. So solving an exponential equation is converting it into log. But step number 1, you want to get rid of this 300. That's the first step. So divide both sides by 300. So it's 100 by 3 equals e to the power of t times ln of phi by 3. Is this clear so far? Alright, how will I get that t? Anybody? This is like saying if it's confusing, just go ahead and think of another equation. 100 by 3 is a number. So let's say this is 30. 30 equals e to the power of t is my unknown, which is x, and let's say ln of 5 over 3 is some number, 5x. If you had something like this, what would you have done? Because this is a constant, this is a constant. What would you have done to get this x by itself? Ln of, perfect, keep going, ln of the output, which is 30, perfect, and then you divide both sides by 5. That's exactly what you're going to do. You're going to say ln of the output will become the input. You have to keep telling yourself that. You have to keep telling yourself this is the output, becomes the input, this is the input, becomes the output. And now you have to write the output, which is originally my input. This is my input. Input is your exponent. Input is the exponent. Because remember, e to the power of x. X was your input. So now it becomes the y. And all of these are constants. Ln of 100 by 3 is a constant. Ln of 5 by 3 is a constant. Which means my time equals ln of 100 by 3 over ln of 5 by 3. That's it. But I need this obviously does not make sense in the sense that I have to approximate, because you need to say what days or hours. No, this will be hours. So go ahead and tell me this is equivalent to how many hours. So now you'll use your calculator. In your calculator you will put ln of 100 over 3 divided by ln of 5 over 3. And again, if you're not sure how to do it, please call me. If they ask you to round it to 2 decimals, then you'll do 6.87, 86, what is it, 86? Depends on what they tell you. Again, if you don't see this, please call me. Everybody okay? Alright, we'll go to the next problem, which is very similar. Okay, I'm going to read it with you guys, and then I'd like you to work on it a little more independently. Okay, so let's go ahead and read it. It says the population of a Midwestern city follows an exponential law. The minute you read this statement, you want to write down your formula. Your formula is final amount equals PERT, which is initial amount e to the power of kt or rt, or doesn't matter what. That's your formula. Okay, so I know that I have to use that formula because it says it follows exponential growth. Okay. If the population decreases from 800,000 to 600,000, so here the AT will be lower than A0 because it's decreasing. So what's my AT here? AT equals 800,000. No, I'm so sorry, A0. We started A0. A0 is 800,000. AT from 1998 to 2000. So what am I looking at? I'm looking at 2 years. After 2 years, my population is 600,000. Is everybody clear so far? Initial amount is 800,000. After 2 years, it's 600,000, and time equals 2 years. What is the population in the year 2010? I will not be able to calculate the population without the rate, without the K. So your step 1, solve for K. Can we all solve for K or R, whatever you may call it? So just for now, just solve for K. You don't have to do anything else. You're going to use your PERT formula. You're going to use this formula. I've numbered the step. I've numbered the step. Please ask me if any of the steps is not clear. Oh. Alright, now let's answer the second part of the question. What will the population be in the year 2010? So what am I trying to find here? I'm trying to find AT. A10, perfect. I'm trying to find A10 when the T is, what is T? From 1998 to 2010. It's actually 12 years. You're trying to find AT when the everything else you know A0 to be the A0 will not change because you're starting with a particular number. How will it change, right? So A0 is this one, and K you already found. You already found the K. K is ln of 3 over 4 over 2. Okay, let's go ahead and find AT. A after 12 equals A0 800,000 e to the power of, okay, I'm going to use a different piece of paper. I'm scribbling, it's not enough space.
If you know it is in 2000, could you do A10 and then have A0 be 600,000?
Yeah. You can, yeah.
Okay.
Yeah. So A12 is what you're trying to find out, and you're starting at 800,000 e to the power of, what is K? ln of 3 over 4. Okay, this is my statement. Can I simplify the exponent? 12 and 2 can be simplified because 2 is really not part of the log. It's just a number by itself. So I can simplify this as, so it will be easier for me to enter it in the calculator. So what I enter in the calculator will be ln of 3 multiplied by 6. Okay, so basically what you're entering in the calculator is 800,000 multiplied by e to the power of 6 times ln of 3 over 4. This is what you'll enter in your calculator. Okay, can we all put this in the calculator and tell me what the final population is after 12 years? So 800,000 is obviously has to be a number less than even 600,000, so it'll be some number less than. If you didn't get this, please let me know so I can come by and help you. Any questions? Okay, we're going to look at a slightly simpler problem, and then I'll talk a little bit about the review. And I want us to do one problem in the review, and then I'll get you guys off. So we're all looking at 2. It's a little slightly different from what the 2 problems that we saw. The 2 problems that we did will be what you will actually be working on mostly, but I just want to see something a little different. So it says a normal healing of wounds can be modeled by an exponential function. So basically what they're saying is when you have a wound, the healing is exponential, means the area it occupies comes down really fast. It comes down really fast. So if A0 represents the original area of the wound, and A, instead of T, they're just calling it A represents the wound after n days, then the function, okay, so I'm going to highlight the function, describes the area of the wound on the nth day following an injury when no infection is present to retard the healing. Suppose that a wound initially had an area of 100 square millimeter. If the healing is taking place, let's just do A. How large should the area be after 3 days? So what do you think we're doing here? First of all, let's look at this. Let's just look at this equation. Does everybody understand this equation? Final amount, final size of the wound is AN. Initial size of the wound is A0. E to the power of, what do you think negative 0.35 represents? If you think about your PERT formula, I know n is my number of days, so n is equivalent to t. So what do you think negative 0.35, R, perfect, rate of growth. And this is a decay. Why is this a decay? Because this is negative. And it has to be a decay. You don't want your wound to be growing, you want your wound to be reducing. So this has to be a decay. So basically I'm looking at it, just guesstimating it, right? We should all be estimating to some extent. It is growing, it is reducing 1/3 every day. So if your wound is 10 inches on the first day or the second day, because 0.35, 0.35 is approximately 1/3. So it's reducing by 1/3 every day exponentially. So that's all. I just needed you to just look at it so that you can analyze these things. So even if an equation is given to you, you should be able to look at it and see what it is. That this is the initial amount, final size of the wound, and 0.35, because it's negative, it is a decay, and it is reducing at 35% every day, because it's a number of days. Okay, that's all I need to do. I just wanted to show you that and this one. But let's quickly look at the review packet. The reason I'm giving you a review packet ahead of time is I just think it's good for you to have it, so that if you want to start working on it earlier, you can. But let's look at one problem, because we are on the roll for word problems, so I think I just want to discuss one. There are 2 problems. There will be 2 problems on the test. I'll tell you straight away. And I just want to look at the first one, and I'll give you the answers. If you guys can take it 5 minutes or so to work on it, that'll be great. So we're looking at question number 43. Okay, I'm going to go ahead and read it. Everybody okay? Everybody got their review and question number 43? Okay. Here it says the population of a Nile virus follows the exponential law. The minute I see this word, you want to be writing your formula. So I will be using this formula. Final amount equals initial amount e to the power of RT. I will use this formula. Okay, so if the population doubled in size over a 15-month period, so I know T equals 15 months. Okay, so I want to warn you of something. There will be questions where the unit of measurement may not be the same. They may say the growth is in 18 months, what will the final thing be in 2 years? Please make sure you're using 24. Please make sure you're using the same unit of measurement to do your calculations. So sometimes they may say years, like in this case, what will the population be 3 years from now? You should be calculating with 36, because the initial problem has 15 months. Okay, so just something for you to think about. Okay, so if the population doubles in size over a 15-month period and the current population is 20,000, that means my initial population is 20,000. and my population after 15 months is 40,000. Okay, they're asking for two questions, because that is how you calculate. The first question is calculate the rate of growth. So even if they hadn't asked, I would have had to do it anyway. Even if they hadn't asked me, I would have had to do anyway. Because for me to answer the question, what will the population be 3 years from now? Okay, so when you're looking at A, what is the rate of growth? It specifically says no decimal. When they say no decimals, that means they want exact answer. That means you want to leave it in the log form, log or ln, whatever you may choose. Probably log. Okay, can we all calculate the R or the K? Let's answer A. So I have A0, I have AT, I have the time. You just have to calculate the K. I'll put up the answer in 2 or 3 minutes. Please let me know if you did not get. I'm not showing the work deliberately. I need you to ask me if you were not sure how to do it. If you didn't get that. Yeah. You want me to show it to you? Oh, you have another question? Yeah. Oh, no, it doesn't matter. Yeah, because I'm using it interchangeably. Absolutely. Anybody else who didn't get that wants to see the work? Everybody good with A? Is anybody still working on it? Can you just raise your hands? I'll wait for B. Good. Anybody still working on A? Ah, okay. Yeah. Sorry, I didn't see your hand. Does anybody need help with K? Finish your work. Now can I go to B? Yeah, awesome. Alright, let's go and read B. The B says, what will the population be 3 years from now? So what are they asking in B? They're asking for what will the population be? So that means I need to calculate A, my final amount after 36 months. Everything else is, I have everything else. I have A0, which is 20,000. E is E. I have K to be ln of 2 over 15 multiplied by 36. You're going to put that in your calculator. Be careful with the parentheses. 15 is not part of ln, remember that. So when you start the parentheses for ln, which is 2, close the parentheses. Divide by 15 and then multiply. So just be careful with the parentheses. Again, I'll be glad to come by and help you if you're not sure, but this is the last thing we're doing. I have assigned some homework for the word problems, 8.7. My advice is, if you haven't done the homework for 9.4, 9.5, please do it. It's good to practice how to solve logs and exponential. But there are different kinds. Unless you practice, it's easy to get lost.